Dave's Dice Game. When you look through this assignment, there's a lot of stuff and it says modules and it says all these things. But what you do is you tackle it one piece at a time. And this program, this assignment kind of takes you through one piece at a time. This is what's going to happen. Dave is taking a statistics class at WNCC. He wants to simulate the rolling of two dice. He wants you to write a dice game for him. Well, you'd think Dave could do it himself, but apparently not. So we want to be able to display two random numbers in the range 1 through 6. And then we want the user to be able to play again. Well, we're not going to do all of that at once. We're going to do one thing at a time. And since this week is about functions, and one of the things that we learned about in our functions tutorial is that functions can live in separate program files. So we're going to create a module called die, which is also going to be a program that'll roll a random die, which means we create this once. We can use this in any program that we need to roll a dice with. We don't have to reinvent the wheel every time. So if you remember from the tutorial, and if you haven't done the tutorial, do the tutorial, it's important. When you have two files in a program, you do have to make sure that you have the folder open, or one file cannot find the other. We're starting with our die module. And I have some, at this point, it's just going to be a module, okay. Oh, no, yeah, it'll start out being a module, then we'll write a main function. There it is, there's my to-dos. Randint, I think we've used randint before to get random integers. So it says, use randint to get a random number between 1 and 6. Well, I have a program somewhere where I've used randint, and that's also why we're taking notes in our Ninja notes as we go. If you took notes of how randint works, you could look in your Ninja notes and find out. Because you don't have to remember all this stuff. Well, when I create a random integer, I want to store it someplace. So I'm going to store it in a variable called roll. Oh no, I can't do that because that's the same name as my function. Dice roll? Yeah, there we go. You don't want to have two things in the same program with the same name. So I'll store my number in that variable. Randint is well, what is randint? Does that look like a function? It is. It's a built-in function in Python. Random is a library that's part of Python. However, we don't have to install it because it's part of what's called the standard library. But I do need to say, and if I point at this, it tells me how to do it. It says, return a random integer in range A, B, including both endpoints. And notice that it says A is an integer, comma, B is an integer. So it's telling me how to use the module. So I want to start at 1. I want to end at 6. So I've done it exactly the way my direction showed me. Now I will get a random number, 1, 2, 3, 4, 5, 6, and my dice roll. Now the important part here is not that I'm solving the problem, but it's how I'm solving the problem. I'm looking things up. I'm looking at parts in the Visual Studio Code editor that are helping me with this. I'm just not pulling this out of my wherever. Now, we have 3 different types of functions. We can have a function that does the same thing every time. We have a function that we can pass things into. We have functions that we can return information from. So it says return random integer. Well, we need the return statement, and what's the name of our variable that is the random integer in it? What is the name of the variable that has a random integer in it? What are we?
Dice roll.
Yes, exactly. So this value will be returned from this module. Well, we really don't know at this point this darn thing's going to work. So the next directions are a little bit iffier, but if you look up my tutorial, it has all this in there. It says use a main method or function to test this. Now, I also showed that you want to do, whoops. Oh, it's not giving it to me. I really copy and paste this from another program. Nah, that's not right. That's why I copy and pasted it. I probably should have put it in this assignment. But I'm making a decision on who wins or loses. How do I determine that?
A condition.
If, yep, like Hope said, if what? If that work, player die is,
Greater than.
it can be either one, yeah. Hope said less than, you said greater than. We'll do that one. Oh, not question mark. Can't get my shift key there. Greater than, of course, computer die. Right? So if the player die is greater than the computer die, what do we do?
Right.
We do what?
Mhm.
Determine who won, or if there's a tie, accumulate wins for each player.
Add to our running total.
So our running total for the player would be player die plus equals 1. Oh no, player wins, sorry. Had the wrong variable. There. Now what else do we have to decide? We have 3.
If it was a tie.
LF,
Player die
yep, player die is,
equal to computer die.
nobody gets it if it ties.
So you would just use print. If you wanted to do that.
We don't care if it's a tie at this point, but we don't really care about ties, do we? You could store the ties in another one. Do I store the ties? No, my example just says who wins. So maybe we want to do if player die is less than and everything else is a tie and we don't care. Or you can track it too. Computer wins plus equals 1. And we really don't care. We're accumulating at this point. And that should be up there. I was wrong. That should be part of this to-do. Now the to-do says, well, I want to know, did I win 3 out of 10 or 5 out of 6 or 4 out of 3? How do I accumulate the number of rounds that I've played?
Running total.
Hmm?
Running total.
Right, but how do I create a running total for the number of rounds? You're correct. How do I do that?
You create a variable for rounds played.
You have to create it up here. We have to initialize it because it's going inside a loop. It has to have a value before we add it to itself. And there are no decisions to make with this one, are there? Each time we play, we add a round to it. And then, yes, we print it out and, we keep going. And we need to call the main function, That's 90% of it. The rest of it is fluff. Believe me, it's fluff. It is. I haven't tested it yet. But I could at least print each of the variables out and see if it works so far. I don't have to get complicated. I can just do player wins. I can use a comma because I don't want to mess around. I just want to see if it works. Computer wins, comma, rounds played. That's one way to debug it. Just to quickly, and then you don't have to do the whole F strings business. You just are making sure everything's working. And then you can make it pretty later. You don't have to make it pretty the first time around. And this is going to be an infinite loop, which is fine. You could have also done what somebody said earlier. You could have printed out stuff in here to test it, you know, but you wouldn't be in your final code. But you can print out things as you go. There is a term for that. It's called print debugging, meaning you're printing out values as you go to see, is the darn thing working? And that's what I'm doing. This is print debugging. It's not beautiful, but I'll know if it works. Uh-oh, it didn't work. What am I missing? Oh, I forgot to call my main function. That's my entrance point to the program. I defined the main function, right? But I didn't ever call it. And you wouldn't have known that because I didn't show you. Oh my goodness, what's going on here? Why is it doing that?
The while loop.
It's an infinite loop, yeah.
You didn't set a
Yeah,
you didn't set a condition for it.
Yeah, I didn't say, oh, do you want to play it again? You're right. But it does work, you know. So you'd want to do some sort of a, oh, do you want to play it again, input, and then exit if, you know, that kind of thing. But it does work. There's no errors. It'll just keep going until the power goes off. Build a program one piece at a time. Test as you go. Print out things to make sure it's working. And then you can make it pretty later once you know it works. That's the important part out of this. Not the code that I typed in, but how I figured out what to type in. Okay, questions? Baguntas. Yeah, the question was, why are there underscores and weird things in here?
Yeah.
These are called Dunder methods, and it has to do with how Python works internally. So when Python runs the main function, that's what it actually looks like when it's running it in code. So if the main function is running, we run this main function. That's really, if the name of the thing that's running the program is main, then we execute that method. If we're importing it as a module, it is not being run as this internal name.
Okay.
But when you don't create a main method, Python always creates a main method, but that's an internal piece that we usually don't do much with, the double underscore things, because that's an internal part of how Python works. This is one of the few times when you bring it out because it has a special purpose of differentiating, are we running it from the main program or are we importing it? And because they're double underscore, they're literally called Dunder methods, which are part of the internal workings of Python. So that's a pretty advanced question for an advanced topic.
Yeah, I just ran into issues with that in a project I was doing, and I've been looking for context with that, and that actually does make a lot of sense. Thank you.
Yeah, you have to do a double, and this is a special method because it has double underscores at the beginning and the end. So they're double special. But in this class, this is the only time we'll ever use anything like this. Only because it's how you do methods and, you know, so you can test your modules before you test it here, because if you try to test it in here, now you're testing two things, and where's the error? In the module or it's here? I added this in early because I found it much easier to test the module first before you use it. You're dividing things up into pieces, which is always easier to troubleshoot. When you're troubleshooting, you're trying to narrow down where is the issue. And the smaller you can break it apart, the easier it is to troubleshoot.